Hey guys, so my brilliant idea was to make this bigger and print it up so that I could write on it better, and that was not necessarily the best plan because I now have one of the questions is out of order, so you're gonna have to bear with me while we skip around. So anyway, it's talking about in humans how albinism is a recessive trait. And in a pedigree, we're always going to show the recessive trait with a lowercase letter. So the following genotypes describe the phenotypes, whether they're normal or albino. So someone who is big A is going to be normal. And someone who's heterozygous is going to be normal. And the way to get the albinism trait is to have both recessive alleles. Okay, so far so good. Like, you could ask me a question. I wish you could. It would be more fun and it would be a lot easier for me to help make sure you understand. So if someone is gray shaded, that means what? They have both of the recessive alleles. So this guy is little a, and we know that she's big A something, but we don't know the other something until we look at the children. In order for this young lady to have little a, which is the albino trait, mom has to be big A, right? Easy peasy. With this kid, they get the little a from mom, and I mean the big A from mom and the little a from dad, and the big A from mom and the little a from dad. How many children does this family have? They have 3. What are the sexes of the children? They're all girls. So let's use female, but I don't have a problem with girls. Okay, so we're going to skip number 7 for now. I hope I don't forget to come back to number 7 and 8 and 9. Okay, so we're going to do number 4, which is on the second page. It just worked out that way, and I apologize. So I'm going to put this right over here so I don't forget. I'll forget. I'm not going to forget. All right, so we know that this dad here is, can you see that? Yes. The dad here is big A something, and the mom is little a. Well, we got a kid who's little a, so dad must be heterozygous for the trait. Okay, so this kid right here got a big A and a little a, because one from each parent, and this kid got a big A and a little a because they're not albino, and this boy married a girl, and when she joined the family, she must be a heterozygous as well. She has to be a carrier, or there's no way for that to work out. She has to be big A, little a. And then this son is little a. How many children does the original couple have? They have 1, 2, 3 original children. This is not their child. This is the wife of this child. How many grandchildren does the original couple have? They have 1. What is the sex of the grandchild? It's a male. It's a boy. Okay, so we did 5 and 6. Let's go back to 7. Confuse you all to heck. So here's number 7. Fill out the blanks in the pedigree below. So we know that this person is big A something, and we know this person is big A something, but guess what? They have this little a kid, a daughter, so they must both be heterozygous for the trait. So far, so good. Okay, we know this guy is big A something. We know this woman is big A something. But guess what? They got this albino kid. Okay. We know that this one is big A something, but guess what? I want you to remember, unless she has children, and even if she does have children, if she marries a guy who's big A, and they have no albino children, it might take till the next generation because we don't know. Okay, so that's how we write that. I've seen it also written big A question mark. I like this because it's, anyway, that's where we are. This person, well, we know he's little a, little a. So do the easy ones first. I mean, obviously the shaded ones are going to be little a, little a. So we know she's big A something, and she must be big A, little a, because they have a daughter who's albino. How many children does the original couple have? They have 2. 1, 2. This is not their child. This is their daughter-in-law. So they have 2. How many grandchildren? They have 1, 2, 3 grandchildren. Okay. So we did number 7. Now we get to do number 8. And, oh, we did 8 and 9. Now we're doing 10. So here's number 10. That wicked Manny. He's so naughty. So Manny sneaks into the cages of 1, 2, 3, 4 white rats, right? And when he sneaks into their cages, he makes baby rats with them. What we're going to do is write the genotypes on top of the rats, okay? And we're going to do the ones that we know that are easy peasy first. Let's do all the shaded ones. They're all going to be little a, little a. So May is a little a, little a. This kid, this little boy kid, this little boy kid. June is a little a, little a. We know that because she's white. These kids are little a, little a, little a, little a. Little a, 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 little a. Because sometimes we can tell the genotype by looking at the phenotype. Now, we don't know what Manny is, but yeah, we kind of do. So think about it. What must be Manny's genotype? He's brown, but he has to be this, right? He has to be this. So when we do the, the pedigree from Sneaky Manny and April, June, July, and May, we know a couple of things. Now, there are a couple of things we don't know, all right? We know that this child got one of her alleles from her dad, Sneaky Manny, and one of them from her mom. Okay, so she's big A, little a. We know that for sure. We're not going to talk about this generation. Oh, yeah, we'll talk about June and Manny's kids. So June and Manny had a boy who was big A, little a, one allele from dad and one allele from mom. And I know it's not little a, or he would be shaded gray. And this girl got one allele from dad and one allele from mom. So she's a carrier, he's a carrier. But now let's not do this generation yet. We're going to wait on this third generation, as it said in the details before the researchers got it all figured out. These guys made babies with their cousins. But anyway, let's come back over here to this mating between April and Manny. This baby's going to be big A, little a. This baby's going to be big A, little a. One from dad, one from mom, one from dad, one from mom, one from dad, one from mom. This baby is going to be one from dad, one from mom, one from dad, one from mom, because remember, if they got that recessive gene from Manny, they'd be shaded in, okay, and they're not. And this baby, same story. This baby's going to be big A, little a. All right, so these two did the rat thing. And we don't know the genotypes of these babies, right? They could be big A, one big A from mom, one big A from dad. They could be big A, little a, either way, again, getting the alleles from mom and dad. Same thing here, same thing here, same thing here. Now, we don't know. And like before, you know, it could show up in the next generation. We could figure it out. It could show up in, you know, like the grandchildren of these children, but we don't know. So I hope you understood this. If you don't, at this point, you know what you have to do. Contact me. Google Pedigrees and watch some more video clips. Khan Academy has a couple. There's a bunch of video clips out there. I was going to turn this into an ed puzzle, but enough of you don't like the ed puzzle that I'm not going to just yet until we practice some more with professionally done ed puzzles. But again, if you don't get this, or if I made a mistake, which is certainly possible, you need to let me know. Talk to you later. Bye.